Everybody can see the Wednesday slide? Good. Okay, cool. Welcome, everybody. If you feel comfortable, I would highly encourage you to turn on your camera so it feels more like we're teaching. But you don't have to if you don't want to. It's just a friendly encouraging. Yes, that's the right way to say it. We always appreciate it. And yay, this is the last virtual lecture. Fingers crossed. Oh, please let this be the last virtual lecture. Next week, we will see all of you in 131 Campbell Hall at the same time. Woo woo. It should be awesome. I know I'm super excited to see all of your faces in person. And I think you'll start getting a lot more out of the course. It'll feel, at least what we saw last semester, y'all will appreciate it so much more being in person, being able to ask questions live, not have to feel the Zoom pressures, not have that easy way out of just like, I won't come to lecture today. It'll be a lot more fun to come to lecture, I promise. So with that being said, I don't know what the situation is with other classes. We have 40 students. We should be able to do it well, and we will have we'll keep the doors open and to let air flow through, and everybody wears a mask, and you know the deal of the situation. I don't know about bigger classes though, so I don't know what they're supposed to do. We have a couple polls from last time. Please fill out the office hour poll if you haven't already. Only 25 people filled it out last time, and it's closing at the end of this lecture. So if you don't fill it out, you won't be able to have a say when we give office hours. So if you can make any time, then that's good. But if you have a tight schedule, we really appreciate your feedback. We'll decide those office hours in staff meeting right after this lecture, and we will make an announcement within the next hour or two. So keep on the lookout for that, and we'll start having office hours because it's timed perfectly with when the homework will drop. So first homework drops right after this lecture as well. So you'll be able to have office hours to support you throughout your homework. And then advanced topics poll, it's not as serious to fill it out, but we have 30 people filled it out already. We need like 10 more responses. This is just for us to get a good sense of what you want to see in the course. So far, there are some strong preferences and some that are not so strong. So we're excited to kind of tailor the course to what you like. Is there any questions? All right, if that's the case, we'll go ahead and get started with today's lecture. Just to refresh our brains, because I went really fast last time. I apologize for that. I'll try to slow it down drastically today. Maybe not drastically, but a little bit more so that it's a little bit easier to follow, and we'll kind of do a little bit of a recap and refresh. So just a basic recap, we went over basic command lines, or command line like commands. So that's how to navigate your computer using only your keyboard, no mouse, in that little thing we call the terminal, that box window. We'll talk about how to use that to get to Python and how to interact with Python in a little bit, because we didn't go over that. And then data types, to yourself, try and remember what the data types are. I'll reiterate them though. It was integers, floats. So integers being, whole numbers, floats being numbers with decimals, strings for like characters and text, lists for lists of things. Tuples are like a list, but you can't change them. You can't add things to them. And you can't change things inside of them. So once you make a tuple, you just have the tuple. And then dictionaries, we didn't really cover. So we'll talk a little bit, we'll kind of go over that a little bit more today. Just, it's not very hard to understand. In fact, it's pretty intuitive once you kind of understand what they're trying to get at. And then we talked about Booleans a little bit. So that's like true or false. True, everything is true unless it's a false, and the things that are false are like things that are zeros or empty. So empty strings, empty lists, empty tuples, empty dictionaries, the number 0, all of those things are, when you represent them as a Boolean value, they're represented as false, like a 1 or a 0 on the computer, basically. And then there was, I think I'm not missing anything. I think that's all of them. At least those are the basic ones that we will be dealing with in this class. There will be more that we will introduce as we bring in libraries of different code that people have, or codes that people have made. But for now, the basics that come with Python, those are the ones you need to know, at least for now. So those are the different types of data that we will encounter. Lecture slides from last time will be posted at the end of this lecture. So the way we tend to do it is we post the lecture slides at the end of the week on Wednesday because they're all on the same slide. So it's just less files for you to keep track of. There's only one file per week, and they'll be released right when your homework for that corresponding material will drop. So you should have them in time. Before we get started, I figured we would do a little bit of breakout room stuff. I know it's not the most fun thing in the world, but it's good to do a little bit of breakout room stuff. And just to get you, talking to people before you go back in person, and to stretch our brains and think about what we did last time. So I'm gonna put you all into breakout rooms. Instructors just stay in the main room. And in this time, I want you to at least answer question 1. But if you feel like it's too easy and you know the answer, then move on to question 2. So like question or challenge 1 is just asking, what does CD, MKDIR, PWD, and LS all mean, and how are they used? And then challenge 2 is like a question saying, if I PWD and the terminal reads this, then how would I get to a new directory, this new directory, if there's no pre-existing folders on the desktop? So if you can see the slides, maybe take a screenshot of this so you could see it while you're in the breakout room, or take a picture with your phone or something just so that you don't forget it. And I'll give everybody about 5 minutes or so to talk about this in breakout rooms, and then we'll come back. Okay, so I'm gonna go ahead and make these breakout rooms. We'll do, there's 40 of us, we'll do 5. Why is it not working? We'll do 5 breakout rooms. All right, so they'll have lots of people in them, hopefully, and yeah, we will see you in like 5 minutes. All right, dope. And I think, is there any, who's still in here? Just Jovi, did I say that right? Jovi or Hovi? Well, they can hear me. How's everybody doing? Nice. We love quiet. I'm going to pause the recording. Dope. Can everybody see the slides again?
Yeah.
Cool. I apologize for putting you in a breakout room. I know they're awful and they're super awkward most of the time. That hopefully will be the last one of the entire semester. Fingers crossed that everything goes well. So thank you for being good sports about it. Does anybody want to volunteer to answer question 1? Did I see a hand from somebody? Maybe. Okay, Charlie.
CD means change directory. MKDIR is make directory, so you can make a new one. PWD is present working directory, so you can see where you are, and LS is list files.
Nice. Love to see it. Thank you. Yeah, did anybody get to question 2 by chance? It's okay if you didn't. Yeah, I see Miguel. Miguel, would you be willing to let us know what you said for that answer?
Yeah, the first thought was to first make the directory with MKDIR and PyDecal, and then CD into that new directory. But beautiful. I think that there's a way that you do it in a single line, but I don't know how.
Maybe there is. Who cares? The basics is all we need. But thank you. That was great. Awesome. Usually Zoom response is never that good, so I appreciate everybody participating on that and taking it seriously. Very much appreciated. All right, let's go ahead and move on. So last time you might be wondering, how do I start coding? You're like, okay, you're showing me Python, but what? And I totally get that. And I apologize for having scatterbrain about that. So we're going to go through how to open up Python and get it working on your computer so you can actually start coding and following along with what I type on or what's on those slides. So we're going to do a new share. Can everybody see this terminal right here? Cool. So this is the command line from last time. And there's a few ways to interact with Python on your computer. So if you installed Anaconda, hopefully everybody installed Anaconda on their computer last week, or if you weren't there at lecture, at least watch the lecture video and try to install it yourself. If you're having problems with that, don't worry, just let us know, probably after lecture, and we can sit there and help you install it, or you can come to office hours when we announce the office hour time. But assuming you have Anaconda installed, and you know you'll have Anaconda installed if you have that little green Ring app, or if you just go to your search on your computer of like apps and files and you see Anaconda somewhere in there. If you did that and it's all installed, you should just be able to type in Python and it'll open up interactive Python like an environment on your terminal. And you could, do a little Python, maybe assign a variable x equals 7 like we did last time, and y is equal to 9, and then do x plus y, and it will output the number 16 for you. Glorified calculator. Now, this is all fun and all, but you'll notice if you want to do things that take multiple lines of code, we didn't really talk about this very much last time, but we will today. Let's say I wrote a bit of code that looks like this, where I have, like multiple lines of stuff, and I have, like 8 plus 2 and blah, blah, blah. And it just gets all weird. I don't know. Let's say you had like multiple lines of code that you want to run. Typically we see that when we're coding. This is awful to do that with. I would never want to do that. You can, but it's not fun. So we're going to leave it. And the way to leave this Python environment is by typing the word exit with parentheses after. This is like an exit function. We'll talk about functions today. And the way you know if you were in a Python environment is if you see these 3 little arrows here. This is like the default Python environment that comes installed when you first install Python. But it's kind of lame. I'm not going to lie. It's not a good way to write code. So I'm going to clear my screen so it's a little bit cleaner. There is another thing you can work with, and this is called IPython. This also comes installed when you install Anaconda, and it's basically like the same thing, but a little different. You'll notice one, it's colored, it's green, and this is kind of like a line. It's like line 1 of your file of your environment that you're working with, and it does the exact same thing. If I do x is equal to 7 and y is equal to 9, and I do x plus y, we should get 16. Or if x is equal to 7 and I do x times the letter or the word high space, then it'll do like high, whatever, 7 times. And we can do all that stuff we talked about yesterday. And it's a little easier to work with because it actually tells you what the output is. It doesn't just give you a line of output. But even this is still not ideal for writing lots of code because 1, we want to be able to say, have all our code in a file that we can just open and close when we want to work with it. And then 2, we want to be able to run snippets of code, whole chunks of code at a time, maybe an entire function that you want to write or something that has lots of lines to it that need to work in synchronized or in a synchronized assembly line fashion. So that's not going to work either, but we can exit the same way. And this is all in the terminal. Now, oh, that's not how you do it. Now, here's the fun part. So on Mac, you just open up a terminal, you'll be able to type this, but on Windows, if you installed Anaconda, you'll have to search for something like, it'll be like Anaconda prompt, not like your command prompt, but your Anaconda prompt if you're on a Windows or Windows machine. And if you just type the word Jupyter Notebook with a Y instead of an I and press enter, it'll do this crazy thing. I think I got something on the chat. Oh, somebody asks, if your command line doesn't work with IPython, perhaps something installed incorrectly. But don't worry, we can talk about that afterwards. you definitely want to open it on the Anaconda prompt is definitely what I would recommend. So you didn't see a new window pop up, but in another, like, because I'm on multiple desktops, but now it'll open up a new, like a tab on your default browser. So when I ran that command Jupyter Notebook, it'll open up an entire new web page with basically like this kind of interface. It's called Jupyter. We made sure that everybody that left on the first day had this up and running and could access this screen. Once you have this screen, then it's pretty straightforward to work with. This is like your files, essentially. So here's my desktop folder, my documents folder, downloads folder. We're at the very top directory of my computer, essentially. So we're gonna go down a couple directories. Like you can tell they're directories because they have these little folders. So now I'm on my desktop, and maybe I wanna go into my Python DeCal folder, and maybe I wanna go to demos, and I have lots of files here. So maybe I'll just make a new file here in this folder, the Python DeCal folder. If I want to make a new Python file or a Python like notebook, I'm gonna go to new and go to notebook and click on Python 3. Now you can run Python in the form of like text files that just run like a script, in the sense that you just press enter and it will run the entire thing for you. If you're used to that, like with C++, some people have different backgrounds. But if you've never seen code before, this is probably the best way to code, in my opinion, as a like data science / astronomer / physics / anything that's not really like writing applets on CS or whatever. So if you go to new notebook, Python 3, it'll open up this really awesome way of coding. And it's called a Jupyter Notebook. Jupyter Notebooks are like amazing. A lot of upper division courses are starting to introduce homeworks in the form of Jupyter Notebooks. So they'll send you a file and you have to edit it and send it back. That's how we're going to do our homeworks. So we're going to upload a Jupyter Notebook file with a whole bunch of stuff in it. And then you're going to edit that file, save it, and then send it back to us in the form of a PDF. You can save it as a PDF. And the reason why this is so cool is because we have this kind of cell structure where you can treat each cell as their own like chunk of code, and you can run that chunk separately. So this is really good for making plots if you only want like a little bit of code to run a plot, or if you have like a function that you're testing and you want to make sure it works before you send it to the rest of your code. It prevents you from having to look through like hundreds of lines of code at a time. It's like bite-sized chunks and you know where it's going. So this works the same way. So we'll do x is equal to 7. Enter y is, oh, I'll actually make this a little bigger for everybody. Is that better? Can everybody see that better? Good, okay. And then y is equal to 9. And then if I do x plus y, actually, I'll show you what I mean by cells. So let's say I just want this little bit of code to be in this cell. I can shift enter, or I could press run, and it will, if I press shift enter, it's like a shortcut. And it's the same thing as pressing this run button. And you'll see that we get this little 1. This means it executed this cell first. And then now x and y are saved in my like Python environment. Like the computer remembers what those are, and I can use them in other cells. So now if I want to see what x plus y is, boom, it gives me an output of 16. It's pretty cool. Similarly, you can do x times y times I space. So, you know, x times y, if we do the little math, x times y is 7 times 9, which is whatever number. I can't do mental math, but it'll be that number times the string. And if we remember what happened previously on the terminal, this should just print out a high like a bunch of times. So now you can kind of work with those data types. And while we're at it, I might as well teach you a little bit about dictionaries, because we didn't talk about those very well last time. So we talked about lists. So I'll just name a list numbers. And for a normal list, right, we have these square brackets that we have to start the list. And then we can put different things inside of this list, maybe numbers, maybe floats, or integers, maybe floats, maybe strings, whatever. But we have to separate each individual thing by a comma. So 8, maybe 6.2, maybe the word hello, and so on. Maybe you could even have another list if you wanted to. So now we have a list called numbers, and if I print what numbers is, print is just a built-in function that allows me to kind of like showcase what I have in a variable. So numbers, for example, just prints it to the screen. Basically the same thing as x plus y, but you can do this anywhere, and it will always, like anywhere within the cell. And it's not super important. This only displays the output if you put it as the very last thing that executes in the cell, whereas this will display it no matter where it is in the cell. So anyway, this is a list, but maybe I wanted to have a dictionary in Python. And what is a dictionary? Well, it's exactly what you would think a dictionary is, in the sense that a dictionary, when you open up the book, right, you look for a keyword and then a value that corresponds to that keyword. So a keyword being maybe, I don't know, hippopotamus, and then you look it up throughout the entire, like you look up in the entire dictionary, you find the keyword hippopotamus, and then right next to it is its value, a definition. In Python, just think a little bit more generally, maybe I can have any key value. It doesn't just have to be a word in a definition, but it can be, you know, a name of a list and the list of values, or it can be like a name of a number or a variable and that corresponding variable. So my dictionary is equal to these curly brackets. So this is how you start make a dictionary, and inside of the dictionary we have these keys, colon, values. So for any key, and every key value pair is separated by commas, just like a list in a dictionary, but the key corresponds to the value. So maybe the word I don't know, sun, has a corresponding value of, you know, the definition, you know, a hot ball of gas. And the way that I assign a value to a key is by putting a colon in between them. So keys always come first and values always come after. And now I'll add another one. If I want to add another key value pair to this dictionary, now I have a whole nother thing, or I set it by separated by a comma, and I could do a very similar thing. So maybe I want to say a very, you know, maybe like X position is like a name of a key, and I can assign like a number to it. So maybe like it has like a, you know, like an X position of 10 or something. Maybe I could do a Y and a Z position or something like that. And now I have this dictionary. So if I run this cell, now it stores my dictionary. And if I go ahead and print my dictionary like this, we'll see it shows me this. Now, the difference between dictionaries and lists that's really powerful for a lot of people is the way you index them. So previously, numbers, like this list numbers, you index it with numbers. So the 0th item in it corresponds to like the 8, the first item in it corresponds to 6.2, and so on. But the difference between that and a dictionary is that my dictionary, can be indexed by their keys. So if I want to look up what the word sun means in my dictionary, I index it by a sun instead of a 0. And now it'll give me a hot ball of gas. So it's kind of it's like a more general list, I guess. That's the way I think of it. It's like a list that you can index with like words instead of just numbers. And there's different things that go wrong with like their syntax and all that you'll explore more on your homework assignment. But that's what I wanted to cover with this. So this is how we interact with Python. We have these Jupyter notebooks that allow us to write code inside in bite-sized chunks at a time, and be able to create what we want to in these notebooks. And this is how most people in the scientific community code using these. Is there any questions about this? Oh wow, there's a lot in the chat. Okay, yeah, thank you for my instructors asking questions. Yeah, you don't have to remember what the index sun is. That's one of the beauties of dictionaries, is that you can just look it up like that. So they are useful. Typically, when you're just dealing with numbers, a list is just fine. But sometimes, you know, you have lots of different things going on, and it kind of depends on style. Some people prefer dictionaries over lists. I personally just go with lists most of the time, but dictionaries can be very useful in that sense. Cool. Okay, so that is what we didn't cover last time, and we can get back to today's lecture. All right, so can everybody see the slides again? Good. Now, let's talk about functions. So this is like what makes Python and any code programming language incredibly powerful. It's functions. So let's talk about them. This is kind of what they look like in code, in Python at least. And we'll kind of walk through the anatomy of them in a minute. They're just like any mathematical function that you deal with in your math class, where it takes in a value or values and outputs some other value. That's basically how functions work. So, oh, that didn't work the way I wanted it to. Another example of this might be I have some values that I want to convert input into a string and attach like a .jpeg at the end. So this might be like, for like dealing with image processing or something. Let's say I have some list, 23,7, and I want to convert, how do I convert that list or whatever into like an actual string that just looks like that, but isn't an actual list anymore, and then add a .jpg to it. This might be really useful if you have like a variable number, and then you have like a little string, and then another variable number, and that allows you to differentiate what these different images are. So maybe like, like my image _0, my image _1, and you have like hundreds of them. You can take a variable and like input a variable and then format it into a string and add a .jpeg at the end of it, and you can create like file images. We'll deal with that later in the course, but that is an example of a function. They don't just have to be with numbers. They could be literally just take in an input, give out an output. So typically when you think of math, you only think of functions in the sense of, taking in numbers, giving out numbers. But now in coding, they could be any input and any output you want to deal with. So they're very versatile. Oh my gosh. So some built-in functions. The print I showed you just a second ago on the notebook, but but there's other ones like absolute, ABS, short for absolute value, max and min. Those are built into Python. So if you want to find the maximum number in a list of numbers, Python already has a function that does that. And the way you call it is with those parentheses. So print parentheses whatever goes inside of the function. So we'll talk about this in a little bit more detail. So let's go through the anatomy. So every function, when you write it, has a define statement, def, that's how you start it. Then you have a function name. So afterwards you have calc_dist is the name of my function. Remember, naming is important. Don't name it A. Nobody's gonna know what the hell that means. Definitely give it like a descriptive name so that people can understand what you're trying to do with this function. So this function is being used to calculate the distance between like a differential x and a differential y. Then our arguments. So these are what we feed into the function, the inputs we give it. We call these arguments in code speak. So dx and dy can be any number. This could be a 1, it could be a 2, it could be a 4, whatever you want. When you call it, you can change that number. So this is like a general dx and a general dy. Then we have a function body. So that's the body, that's the heart, the meat of the function. It's what's inside the variable name, and it's kind of like what's happening. What is it's what the function is actually doing. So in this case, we're calculating the square root of dx squared plus dy squared, and then assigning that to a variable called dist, short for distance. And then we return that whatever we want in the function. So this is what, like if I call calc dist and then give it like 1 and a 2, it'll give me the distance. Like if one side of a triangle is 1 and the other side is 2, it'll give me this distance, this hypotenuse. And then we return that. So that's like the output. Yeah, it's like a sandwich. You can think of it like a sandwich, where the bread is the name, and then the top bread is the name, and the bottom bread is the return statement, always. I mean, maybe not always, but it's good practice to do it that way. So now let's talk about advanced functions. This is basic, like just a very basic function. But now let's say we want to get into some more fun stuff. So how do I make more complicated functions that you might have seen in your physics classes, or you might eventually see in your physics classes? Ones that look disgusting, like this, as like, with differentials and like different, all these different constants and temperatures and radii and gross, like this is like partial differential equations from fluid dynamics. Like these are disgusting. So we need to be able to better equip our arsenal to deal with more complicated functions. But before we do that, we need to start talking about variable scope. So this is a very basic idea for like a computer scientist, but typically gets overlooked for anybody who doesn't study computer science. So every variable is either global or a local variable in Python. And now, what do I mean by that? So variables that you assign outside of functions are called global variables. These are recognized everywhere in your entire code, in the entire notebook. Whereas inside, if you assign a variable inside of a function, it's called a local variable. So what do I mean by that? That means that if I reference that variable outside of the function, nobody knows, like the rest of the code doesn't know what you're talking about. It's only local to that function. It's like an inside joke, you can think of it that way. So in this case, G is a global variable. I assign it outside of this luminosity function, where I take in some radius and some temperature, and then I do some calculation, and then I return the luminosity, how bright a star is, for example. But G is a constant. G doesn't change, as far as we know. G is just a constant that everything can use. So why not assign it outside of my luminosity function? Same thing with pi. That doesn't change. It's a constant. So these are global variables. But a local variable would be something like temperature, right? Because temperature is assigned inside of the luminosity function. It's one of the arguments. But outside of this luminosity function, temperature doesn't mean anything. It's like, think of like, like in your house, you have like family, and with your family, you have inside jokes, things that only you and your family understand. But as soon as you leave the outside into like leave your house and go to the outside world, those inside jokes don't mean anything to anybody else. That makes sense. So that's like a good analogy to think of local and global variables. And it's important for this, it's important to understand this because it's often a very easy thing that people don't understand when, or that cause errors in Python for beginners. Does Python have any built-in global variables? Well, the name print, the name abs, max, min, those are already functions in Python. So those are like names that are stored, or variable names that are stored to or functions are actually stored to. So yes, it does have built-in global variables. Cool. So demo time. Let's play around with this. We only have 10 minutes left, so I'm just going to go back to that notebook that I was using. Hopefully y'all can see this. Ooh, wrong one. So let's just play around with writing a function. In fact, I have this one already written. So we'll just take this one and copy and paste it. So again, G is a global variable. Pi is a global variable. Sigma SB is a local variable because it's defined inside of this luminosity function. And L is a local variable, and temperature is a local variable. So let's say I have this code. Again, this is multi-line. This is what I was getting at earlier. This is why when you're coding on the terminal, it's not fun, because doing this always leads to errors and stuff. So having the Jupyter Notebook is amazing. Now, let's run this code. Well, it didn't output anything. And there's a reason for that, because we haven't actually called this function. We've only defined what it is. So we've only told the computer what the word luminosity means in Python. So if I just type the word luminosity, there we go, can't type. You'll see it gives me this whole thing. I don't even know what this is, but it says function. So it tells me that the word luminosity is actually a function. So you can call a function a data type, technically. You can think of it that way. So the word luminosity corresponds to this function. And now if I want to actually use it to give me some values of L, I actually need to give it arguments. So the way I call this luminosity function is with these parentheses. This is making a call to the luminosity function. And if I just run this, it's going to give me an error because it's expecting me to give two required arguments, radius and temperature, because I defined it that way. It needs a radius and it needs a temperature. So let's do that. Let's give it 1,000 radius, like just some number 1,000. I don't really know what the physical scale is. This maybe meters. It's going to be really tiny, and a temperature of 10,000. So now if I run this, it'll give me some huge number that I don't know what that is exactly. Maybe SI units or something for joule watts. I don't know, something, but it's a number. It gave me an output. When I gave it a radius and I gave it a temperature, it took this radius value 1,000 and carried it through the calculation as if it was just the number 1,000. And then same thing with the temperature, and it gave me the corresponding L that my body calculated. So this is the return, this is the body, and this is the this is the defining statement with the variable name and the arguments. Is there any questions about this? Oh,
question.
Oh yeah, go ahead.
If when you're creating your function, if you assign default values to your variables, well, first question, are you able to assign default values when you're creating your function? Like if for radius, I told it that radius is whatever, when I'm creating the function, can I do that? And then secondly, if I do that, when I call my function, do I have to give it variables since I've already said default ones?
That's a good question. Yeah, so there is a way to assign default values to these. Maybe like it's not super important that a user knows what the temperature is. Maybe it's like, just like most of the time it's just this number. So if you want to do that, then you can just write an equal sign and then give it a value here. So you're saying temperature is usually on default equal to 10,000, but I can always change it afterwards. So I can make this 10. So if I run this and then I run this one, it'll still give me a different value. But if I got rid of that argument altogether, since I put this equal sign here, it'll just use 10,000 again. It's not super important that you knew that, but it is a thing you can do. I would like to point out though, that the way when we write functions, notice that there's an indent here. Python is indentation sensitive. So if I give another tab, it's going to give me an error because it's too many indentation levels inward. So every time you write a function, anything that goes inside of the function needs to be indented by one tab space. So just type tab, and it'll tab you over, and it will keep you tabbed over until you are done, and then you leave. So everything that's tabbed in one level belongs to this function. Does that make sense? Okay. Yeah, so let me go back to this idea of global functions. So some basic ones that you will become very familiar with is print. So all this does is just print whatever's inside of it. But you might be wondering, okay, well, what happens if I just type hello? It does the same thing, or it looks like it does the same thing, but they're not. They're not the same thing, because if I write something afterwards in my cell, let's say I write the word hello, but then I also write 8 + 7 afterwards, or do some code, or maybe I'll do z is equal to 8 + 7, assign some variable, and I continue doing my my code or whatever down here. But I wanted to show this word hello. Well, if I run it, the same thing as pressing run, it only prints 20. You might be like, okay, what happened to the hello? Well, all it's doing is giving me the output of whatever is the last line is. So that's why we need to use the print function. This will print it no matter what comes after, unless there's like an error or something, but it will print no matter what comes after. So hello, and then it gives me 20. So and whenever you want to display something, you should use the word or the function print. Yeah, okay, cool. So now let's play around with some other ones. Let's say I have a list of values, 1, 2, 3, 4, 5, 1,000. And we'll assign this list to a name. Be super original, call it name. And then let's say I want to find the maximum value of name. All you do is just use the max function and then put in a list. Put in a list called name, and it should just give me the maximum. Same thing with the minimum. Max, min, easy. Those are some built-in functions. There's also absolute. So absolute value, give it -10, and it should give me a 10. Works how you expect. We'll get into more functions that are available at your disposal later when we learn how to import libraries. Give you a little taste of it. Let's say you wanted to use a math, like a thing like sign. You wanted to use a function called sign, but coding that up is actually kind of difficult to like from scratch. How do you code up a function that gives you the value of sign? Those are functions that you have to import through a library. And we'll get more into the weeds of this later. But if I import math, if I import the math library, just import math. Math is like an entire library or suite of code that people have already written up. That's kind of like part of the default Python. When you install Python, it's just already in there. But you have to import it because it has a lot of names and stuff to it. So you don't want to cloud variable names and have a ton of global variables running around. So you have to import it. So you import this library math, and this is tons of files with code that calculates all sorts of functions for you. So you don't have to write them from scratch. So if I run this, right, it'll import this math library, and I can use functions just like absolute or min or whatever from that library. And the way I access them is I do the name of the library, math dot whatever function I want. So sign. So if I want to calculate the sign of 1, now I have access to the sign function. It's just part of the math library. Okay, so now I have tons of stuff at my disposal. I could do math.cosine. I could do math. I don't know, sinh. Like if I there's like tons of functions in here. Exponential. You could do exponential like e to the whatever, and so on. So those are like functions that I can import with a library, and there are tons of libraries. There are so many libraries out there that I couldn't name all of them if I tried. Millions or probably not millions, but hundreds of thousands or tens of thousands, something like that, with code that can do just about anything if you look for it. There's a library that you can install or that you can import into Python that allows you to detect faces from your webcam. Like they could be anything. So the world is your oyster, and we'll show you tons of libraries that allow you to do scientific programming. I realize it's 4 o'clock and people do have to get going, but I really, really want to show you a couple things. And somebody asked, what do we expect for the homework? We will give you a Jupyter Notebook file just like this. We'll post it on B Courses. It'll be under the Files tab. You'll download it, put it somewhere where you can find it in the directory. So right, if you do that command Jupyter Notebook and you have this file, maybe put it on your desktop so it's easy to find and you can access it. And the way you'll know if you can use it is if there's this notebook icon. So there's like this little, I don't know if you can see that exactly, but there's this little notebook icon, and that's how you know it's a notebook. And we'll send you one of, or we'll upload one of those, and you can download it and work on it and save it. That's all great. I just want to show you one really cool example of what I just taught you today. That's beyond just numbers, because that's all cool and all, but it's not super fun. So there's this library I found called Musical Beeps that allows me to play music on my computer. So hopefully everybody can hear my audio. I don't know if you could hear that, but I'm importing like some code from it, and it allows me to play musical notes. So I don't know if you heard that, but you can like hear a little beep. So I used that, and then I decided I wanted to write a function that uses it as part of my code. So I wrote this function, play Mario. It doesn't take in any arguments, but it just has some body of code, and don't really worry about exactly what it's doing or how it's working. That'll come later, but I'm writing it so that it can do some command line stuff or whatever. But it's using the library to do some to play some music. And now if I have my body, my function, I return nothing. I don't want it to return anything, but I have this function. If I assign it a variable name and then I call it, you should be able to hear this. Okay, that was it. I wanted to show you that because I thought it was cool. Took me forever to find all the notes to Mario, but I did it and I typed them all in and I got it to work like that. So yeah, that's a cool example of how you can use functions to do things other than just doing stuff with math. They're pretty like, you could do so much with a function. Anytime you want to take something in and do something out, perfect. Or if you just want to accomplish something, typically functions are your key to do that. I'll see everybody next week in person at 131 Campbell on Monday, same time. So, I'm looking forward to seeing you. Office hours announcement will be posted today after lecture. And yeah, homework will be dropped today. So we look forward to seeing you next week.
Thank you. Hello. I have a question.
Yeah, what's up? Oh, let me
well,
stop recording really quick.
Yeah, I have two questions.